All right, so the directions say find domain x-intercept vertical asymptote of the log function and sketch its graph. So I'm actually start by plugging the points, sketching it, and then answering the questions. The order obviously there doesn't matter. So I'm going to change this so that it is a y equals log base 4 of x minus 5. And then I'm going to convert that into exponential notation, which is 4 to the y equals x minus 5. And then add the 5 to the other side. So 4 to the y plus 5 equals x. And now I'm plugging my values in for y. So same 3 values I would typically use, except this time I'm plugging in for y. So 4 to the negative 1 plus 5 is 1/4 plus 5, or 5 1/4. Four to the 0 plus 5 is 1 plus 5, which is 6. And 4 to the first plus 5, which is 9. So when I plot these points, I get 5 1/4 negative 1, 6 0, and 9 1. And here's what my graph should look like. My vertical asymptote comes from this part of my log, whatever's inside the parentheses. So if I were to set that equal to 0, I would get that there's a vertical asymptote at x equals 5, which is consistent with what I drew. So that's one piece of information it's asking for, vertical asymptote. X equals 5. It's also asking for domain, which that's going to impact, right? Because the smallest value that x can be starts immediately after that 5. So my domain is 5 to positive infinity. It asks for my x-intercept, which I can either get from my graph or from my points, but either way I'm looking for where y is 0, which is 6 0. Questions on any of that? So make sure you're able to plug in the points, make sure you'll be able to find that information. If it asks for range, it would be negative infinity to positive infinity, right? Range and domain switched on the exponential and the logs.
So on exponential, what is the domain?
Domain is all real numbers on exponential, and it's all real, and range is all real numbers on the log. So those switch.
This is a quiz question.
Yep. Well, I mean, the same numbers, but yeah. You will be asked to graph a log and identify all that information. It actually says range on there too, so you might as well add it on. Negative infinity to positive infinity. All right, so the last part of this section is natural logs. So if you remember, E was the natural base. When I find the log of E, it's called the natural log. So a log function with base E is called natural logarithmic function, okay? ln is how we show it. ln is the same thing as log base E. So it's like finding log with the base of 2.72, because that's what we estimate E to be. Because it is a log, it follows all the characteristics of everything we just talked about, okay? So it will look just like all the log graphs that we've already done. The domain is all real numbers greater than 0 unless there's a horizontal shift. The x-intercept is at 1, again, unless there's a horizontal shift. The range is all real numbers, so it's all the same characteristics of a log. Say that again.
What's under x? So 1 or comma?
Oh, it's a comma. Yeah, an ln of x. So the difference is you won't be expected to know log base E without a calculator. You can find 3 to the first and 3 to the second and all that stuff, but I don't expect you to find 2.72 to the second power or 2.72 to the negative, that kind of stuff, okay? So you'll use, that's one of the reasons why you need a scientific calculator. Yesterday or the day before we were using the E button. Now you're using the ln, which is not hitting second. Okay, it should be right there on your calculator. So this one just says use the calculator to evaluate the function at the indicated value of x and then round the answer to 3 decimal places. So 2 ln of x would be 2 ln of 12.5, and you type it in and you hit equals and you let your calculator do the work. This is 5.0514, so 5.051. Okay, example 11 says use the property of natural logs to rewrite the expression. So think about what's happening here. Negative 5 ln of e. If I rewrote that as log base e of e, because really that's what that is, right? Ln is the same thing as log base e. What happened when I rewrote it?
The e's cancel.
Good. So that is the same, right? Log base e of e is 1. You with me? So this would be negative 5 times 1, which is negative 5. When you see ln of e, replace it with 1. So it doesn't cancel to give you 0, but it replaces it to give you 1. It's like having the base and the larger part of your log to be the same. So ln of e equals 1. Make your life easy. Memorize it, okay? Because it's the same thing as saying log base e of e, and if the little base and the big number are the same, then it's 1, right? Because you would have to raise e to the first power to keep it e. Does that make sense? Yeah? Okay. So then b, e to the ln 7 would be the same thing as saying e to the log base e of 7. So it's 7. If you rewrote that in log form, this would be log base e of x equals log base e of 7. 1-to-1 property cancels those out, and x would be 7. So whether it's e to the ln or ln e, you're going to cancel it through, and you would keep whatever's next to it if it's an exponential form, okay? Yep.
How'd you get e log? So iron is like log e.
Ln. So ln is log e. Those are the exact same things. They just shorten it. All right, now you're doing find the domain, x-intercept vertical asymptote of the log function, and sketch the graph. So my advice is to convert this into log base e. So this is y equals log base e of x minus 3. It follows the log because it's still a log. It's just that your base is 2.72. That's all. So now it becomes e to the y equals x minus 3 e to the y plus 3 equals x. And then do everything we just did with the other log graph. So plug in for y. This time you're going to need, well, sort of, need the help of your calculator. Although if you approximate that, you probably wouldn't. All right, so I convert it into exponential, and then I plugged in my points. I got 3.4 and -1, 4.0, and 5.71. I know it takes the shape of the log function, which would look something like that. My vertical asymptote comes from the same place because it has all the same properties of a log, right? So I would set this equal to 0, and I would get a vertical asymptote at x equals 3. which means my domain starts at 3, goes to positive infinity, can't include the 3, so it gets a parentheses. And my x-intercept, either from the graph or from my set of points here, would be 4, 0. Range on this is what? Good. Bottom to top, negative infinity to positive infinity. Questions? So you're going to get 3 graphs. 2 are exponential, 1 is log. Something's going to involve an e. Make sure you know how to use your calculator to get it, okay? And you're going to answer all those questions based on those. And then the rest of it is, so fraction 1, it's really just the graphs of exponential. This is for your quiz. So 3.1 and 3.2 quiz. Graphs of exponential. And your interest problems. So you need to know A equals P times 1 plus R over N to the NT. And A equals PERT. That's 3.1. And then 3.2 was logs. Graphing the logs. And using ln, which is the same thing as log base e. And again, scientific calculators. Bribe a friend. You really, by the time the test comes, I'll be able to separate off the graphs. I just don't want to kill a piece of paper per kid in here to do a quiz on 2 different parts. And you can't do the interest without it, but I'm not going to give you a graphing calculator and then give you a graph. I'm just not that person. Okay? Questions on expectations for the quiz. So we went over the graphs. It's going to do the same questions: domain, range, intercepts, vertical asymptote or horizontal asymptote, and then obviously plot your points. There's, I'll post it now, I'll publish it now. There's a quiz review, okay? And then also your 3-2 homework will be due tomorrow. The quiz review, I'm going to post the answers. Do as much of it as you need to do, okay? But make sure the 3-2 homework gets turned in.